introducing the active and passive circuit elements, which are illustrated on this particular main slides as well. Active elements are capable of generating electrical energy. They are represented as voltage or current sources. We know them commonly as generators or batteries. Passive circuit elements, they are not capable of generating energy on their own and continues to draw the current. However, they are having some role to play and important role to play, but their effectiveness is experienced only when the circuit is energized by a source. So for an active circuit, there is a requirement of at least one active element or one active source. Active elements can be classified on the basis of the nature, ideal sources, practical sources, and the dependent sources. Ideal and practical, they can be considered under the category of independent sources. So dependent sources and the independent source, that is one classification. Passive circuit elements, they are the resistance, inductance and capacitance likewise. So broadly the components are classified like active and passive, that is one classification. Active elements are further classified into the independent sources, dependent sources. Independent sources can be voltage source or current source. They are represented as ideal or practical nature. The dependent source, where say the voltage or current level depends on the voltage and current associated with some other elements. So when say there are two controlling parameters and two controlled parameters, so that is resulting into the four such dependent or the controlled sources. We will be discussing them one by one. So that discussion is carried out first with the ideal source. We will be moving to the practical source, then we will be considering the dependent source. So here say the voltage source, there are two representations for the voltage source. One particular is a battery symbol. This battery representation is for the DC circuits, where say the another one is circle with the plus minus sign, that is for both AC as well as DC. When we are saying the plus, it is at higher potential with respect to the lower negative terminal. Now the ideal voltage source is a source that can maintain the specified voltage across the terminal irrespective to the current supplied by the source or current drawn by the connected load. So if suppose we are taking the I as a variable on the x-axis, then the voltage is on the y. So this particular is having a representation like this. As the current level is increasing, the voltage is maintained constant. Ideal voltage source, there is also a representation of the ideal current source. So current source is represented by a circle with an arrow. This arrow points to the direction of the current supplied. Ideal nature suggests that the source is able to maintain the current level as specified irrespective to the voltage likewise. So on this particular I am taking the voltage, on the y axis it is the current. So that particular current level is maintained constant irrespective to the voltage. So you please note the change in comparison to the previous one. I have changed the variable on the horizontal and the vertical axis. Now the ideal sources are basically an oversimplification. They are not realizable in practice. So in practice they are not able to maintain the ideal characteristic, and we are starting with the voltage, let's say. So the voltage level decreases with the increase in the current loading or increasing the current level. So this particular drooping characteristic is facilitated by, or you can say represented by the mathematical relation V is equal to Vs minus IRs. So as say the current level is increasing, the drop because of this IR is increasing, and that particular is resulting into the decrease in the terminal voltage. This equation is translated like this. So the resistance is added in series with the voltage source. Now this particular resistance is also sometimes regarded as the internal resistance of the source. The characteristic is plotted. It is resulting like this. So our AC and the DC generators are basically the practical voltage sources. Similar to this practical voltage source, there are say the analogous practical current source. They are also not able to maintain the current level with the change in the voltage level. So as say the voltage level is increasing, there is a decrease in the current. So to facilitate this particular representation, there is a mathematical relation, likewise I is equal to Is minus V upon Rs. So here say the internal resistance is represented in parallel with the current source. Now although I am saying that the solar cell can be a practical example of a current source, however, when say we are connecting a large inductor in series with a voltage source, it is emulated as a current source. Now the two representation, practical voltage source and the current source, are the representations of the actual phenomena. Mathematically, we can translate or transform one of the source into the analogous representation into the second form. So like say, if I am looking to the voltage source equation, V is equal to Vs minus IRs. This particular is divided by Rs and rearrange the variable. So if suppose say Vs upon Rs is designated as a Is, then this particular equation coincides with this particular equation. So mathematically or pictorially, we can transform the voltage source into the current source or current source to the voltage source. The point which is to be noted here, in the voltage source, the internal resistance Rs is connected in series. Here say the internal resistance Rs is coming out to be in parallel. Having gone through the ideals and the practical sources, now I am introducing the controlled sources. So first of all, there is a difference in the representation. They are represented by the diamond shape arrangement. If suppose say the plus minus is indicated, it is representing a voltage source. If there is an arrow, it is representing a current source. So when say it is a controlled source or the dependent source, there is a controlling parameter. The controlling parameter is the voltage or the current associated with other circuit elements. So there are say the two controlling parameters. There are two controlled parameters which can be voltage or current. So these particular combination is giving rise to the four such sources likewise. Now the value of these particular is dependent, that particular is highlighted. So the four possible values are voltage controlled voltage source, current controlled voltage source, voltage controlled current source, current controlled current source. Now we will be visiting them in one by one manner. Voltage controlled voltage source. So here say the controlling parameter is the voltage Vxy. Controlled parameter, that is the source value, that is also a voltage, that is VAB. So we are if correlating VAB will be like this. So the dimension of this alpha is a voltage ratio. Normally you can say the transformer, operational amplifier are the examples of the voltage controlled voltage source. In case of transformer, the secondary voltage depends on the primary voltage multiplied by the turns ratio. Similarly, in case of operational amplifier, the output voltage depends on the differential voltage input. Similarly, in case of the current controlled voltage source, the controlling parameter is the current Ix, controlled parameter is the voltage value VAB. So when say you are correlating this, the dimension of this constant R is coming out to be that of a resistance. Now this particular is not the actual resistance present in there, so there is a name trans resistance. Our generators are basically the practical example of current controlled voltage source, where say the output voltage depends on the field current. Voltage controlled current source. So here say the controlling parameter is the voltage Vxy. Source value is the Ia, which is a current. When you are writing this into the equation form and taking the dimensions into the mind, so the G is having a dimension of current upon voltage, which is the conductance. As mentioned previously, it is not the actual conductance present, so there is a nomenclature of transconductance. The famous example is the MOSFET. The last in this particular category is the current controlled current source. So this particular is a controlling value Ix, controlled value or the source value is Ia. When you are combining this into the form of equation, you are finding that beta is the current ratio. Likewise, the famous example is the BJT, where say the collector current depends on the base current value. So this particular is giving you a glimpse of all the active sources, active elements. Now as a summary, they can generate and deliver the electrical energy. Ideal sources are as an approximation, they are not realizable. The most common electrical generators are basically the practical voltage sources. Practical current source is realized using the large series inductor with the voltage source. The dependent or controllable source are commonly realized through the electronic circuit elements. And lastly, the practical voltage source can be represented as an equivalent practical current source, or practical current source can be represented as an equivalent practical voltage source. So next we will be discussing the passive circuit elements. It is clear in the beginning that the passive elements are not capable to supply energy on their own. However, they are having important role to play in the circuit. Their functionality or effectiveness comes into existence when the circuit is having an active source. They are always drawing the current, so therefore the terminal through which the current is entering is having a higher potential, or you can say there will be a voltage drop across the terminal when we are traversing towards the direction of the current. These particular are the resistance, inductance and capacitance. Resistance is the property of the circuit elements which denotes its ability to resist the flow of the electric current. This particular is expressed by the relation rho L upon A for a cylindrical conductor, where say rho is the resistivity of the conductor, L is the length and A is the area of cross section. On the basis of this resistivity, we can classify the materials into the categories like the conductor, semiconductor and the insulators. The good conductor must possess the low resistivity, where say the insulators are characterized by the high resistivity. On this particular basis, we can recollect that the copper and the aluminum are normally used as a conducting material because they are having say the low resistivity. Silver, although having say the lowest resistivity, but that particular is costly and that's why it is not used as a conducting material for practical purposes. These electric resistors, if I am saying, are made of the metal alloy or the carbon compound. If suppose you are recollecting the Ohm's law into perspective, which is suggesting that the voltage drop across the resistor is directly proportional to the current through it. So this particular is a representation. Current is entering from the left, so this particular left terminal is positive with respect to right. It is experiencing a voltage drop. The power is always positive, V into I is always positive for the resistor, and it is continuously dissipating the energy. The reciprocal of this particular resistance is the conductance. So, as say the resistance is the property to exhibit to resist the flow of the electric current. Conductance suggests the ability of the element to conduct the current. We are considering the linear elements, so for practical purposes they are the linear under consideration. However, some amount of non-linearity is always demonstrated in the practical resistances. Resistance is greatly influenced by the temperature, and the temperature dependency is explained by the relation likewise R0 1 plus alpha T minus T0, where alpha is a resistance temperature coefficient. This particular is having a positive value for conductors, whereas its value is negative for the semiconductor and the insulators. So this particular is an interesting aspect, why it is positive for the conductors, whereas why it is negative for the semiconductors and insulators. So this we have to see that in conductors, when say the temperature increases, there is increase of electrons, but that particular is resulting into the interatomic collisions inside the conducting material, and that particular is restricting the free flow of electricity. So that's why that restriction is represented as increase in the resistance, and that increase in the resistance is suggesting alpha is positive. Whereas in case of the semiconductor and insulators, where say the number of carriers are limited initially, so because of the temperature increase, the number of carriers are increased, which are facilitating the flow of current, and that facilitation is basically reflected as negative value of the alpha. So these are, you can say, the various representation of the resistors when used for various purposes, and when you can say has been used by various standard agencies. Capacitor and the inductors are also the passive elements, but they are having say the different behavior than the resistor. Resistor is continuously absorbing the power and dissipating the energy, whereas the capacitors and insulate inductors do not dissipate the energy but store the energy. It will be clear that the inductor stores the energy in the magnetic field, and the capacitor stores the energy in the electric field. This stored energy can be retrieved at a later time instant as and when needed, or the way we are controlling the circuit. Now the interesting aspect is that these elements takes power from the circuit when storing the energy, and delivering power to the circuit when returning the previously stored energy. So this energy is just acting as a, this storage of energy is acting as a memory. Inductance is the property of the circuit element which exhibits opposition to the change of current flowing through it. It stores the energy in its magnetic field. The unit is Henry. So this particular is only a schematic representation of a inductor. So this basically is a coil of conducting material is bound on a magnetic core. So corresponding to this, when say there is a current, there will be a flux. That particular flux is measured in terms of the flux density and the area of cross section. This flux density is related to the magnetic field intensity. Ultimately, the flux is mu Ni upon L. So inductance is regarded as a flux linkage upon current. This flux linkage is associated with N phi upon I. The expression of phi is substituted from this, so it is resulting into N square mu A upon L. We will be dealing with various aspects of the core construction, etc., while say discussing the magnetic circuits. But the voltage current relationship of the inductor is expressed by V is equal to L di upon dt. So this particular expression suggests that the voltage across the inductor is directly proportional to the time rate of change of current through it. However, current through an inductor cannot change instantaneously. This particular has to be understood while say we are having on the right hand side the derivative of the current. So that particular current cannot be changed instantaneously. Now to justify this particular, there are say two hypotheses. One is because of the current there will be a magnetic field. Because of this field the energy is stored and the energy cannot be changed instantaneously. So that suggests that the current cannot be changed instantaneously. Another hypothesis is because of the change in the current there will be a induced EMF in the inductor, and that induced EMF itself will be opposing this change of current. So because of these two reasons or two interpretations, you can say that the current in the inductor cannot be changed momentarily. If suppose you are looking to the right hand side expression di upon dt, so for the DC di upon dt value will be 0, that particular is resulting into V is equal to 0. So that suggests that for DC it is working as a short circuit. Now the energy, that particular is well known, W is equal to half Li square. So this energy depends on the instantaneous value of the current. This differential equation can be represented into the integral form, and this integral form itself is suggesting that it is having a memory because the value depends on the previous states. Likewise, we will be considering this as a linear element, so that linearity is to be understood between the voltage and the derivative of the current. Likewise, analogous to the inductor, the capacitance is a property of the circuit elements which exhibits opposition to the change of the voltage. It stores the energy under the influence of electric field. So basically it is working as a energy storage or the charge storage when say the voltage is applied. However, it can be retrieved as and when needed, or you can say when say the voltage is reduced. This particular is the expression of the capacitance for a parallel plate capacitor. C is equal to epsilon A upon D. Epsilon is the permittivity of the dielectric material between two parallel plates. A is the area of the parallel plates. D is the separation of the plates. So as suggested that it is working as a charge storage. So in case of inductor, the inductance was expressed as the flux linkage upon current. Here say the capacitance is defined as charge upon voltage. On the analogous line, the current voltage relationship is expressed by I is equal to C dV by dt. So dV by dt suggests that this particular is exhibiting opposition to the change of voltage. That particular is one aspect. dV by dt is also suggesting that the voltage cannot be changed in a capacitor instantaneously. So on the analogous line you can have an interpretation if the voltage has to be changed instantaneously or not. So not, because the energy is stored in the electric field, which is directly related to the voltage. So if suppose say the change in the voltage has to be instantaneous, the energy has to be changed instantaneously, which is not possible, and that's why the voltage cannot be changed instantaneously in the capacitor. If suppose you are looking for dV by dt for the DC, that derivative will be 0, and that is suggesting the I value has to be 0. So this I0 is represented as open circuit for the DC. On the analogous line, the energy stored, energy associated with the capacitor is expressed like half CV square. So this depends on the instantaneous voltage. However, if you are obtaining the voltage expression from this derivative expression, this particular is having an integral, and that particular is depending from minus infinity to t. So you can say this is also having a memory. We will be dealing the linear circuit arrangement, so that linearity has to be established between the current and the voltage. So here says it is a current, but on the y-axis it is dV by dt. So that particular is the characteristics. Now these particular is we discuss the passive elements, resistance, inductance, and capacitance. So this particular is a summary of all the relations which has been used previously. So the same relation for resistance, that is R is equal to V upon I, inductance flux linkage upon current, capacitance C is equal to Q upon V. These particular equations can be used to find out the voltage when say the current value is known. So that particular V is equal to L di upon dt, the integral form 1 upon C I dt for the capacitor. If suppose say the voltages are known, we can calculate the current likewise. The energy expressions are there. So we summed up previously that the inductor is having the energy half Li square, capacitor is having the energy half CV square. But the expression for the resistance was not highlighted as such, but the resistance is always absorbing power. So V into I is positive. When say you are translating that into the energy, it is suggesting that it is always dissipating the energy. So in the resistance, the power is always positive and the energy is dissipated. Inductors and capacitors are the two energy storage elements. They draw power when storing the energy and delivering power back to the electric circuit when energy is returned back to the circuit. So these are all you can say regarding the passive elements. Next, we will be discussing the circuit laws. For further reading, you can refer the textbook. Likewise, thank you.